Hello, my name is Nicolas Ivanom and I am the CEO of Funartech, a startup in artificial intelligence from Montreal, Canada. And I'm really happy to be here with you in Korea. We are working on artificial intelligence and we are solving complex industrial problems. We're doing AI, but a little bit differently in the sense that we are combining machine learning and other mathematical fields like operations research. You probably know what machine learning is. Operations research is one of the best science of optimization. And our expertise is really to combine both or even other fields to solve complex industrial problems. We're doing research and we are solving industrial problems. Compared to solutions that are not using our approach, we are able to improve, optimize by 20, 30, even 40%. Let me show you an example of what I mean by solving industrial complex problem. We worked with the ASIN group, Toyota, on a huge logistic problem where automotive parts needed to be moved from depots, warehouses. And we worked with the ASIN group for 6 months and we could improve by 30% the cost of their huge logistic problem. We got in contact with them thanks to a contest and we actually won the contest. So we were the first company out of 800 AI companies. And our results are really thanks to that hybridization of ML and OR. I'm happy to say that we are continuing to work with the ASIN group and we now started our second project with them. What do we do? Whether it is research or solving a complex industrial problem, we basically answer 4 questions again and again. So we construct systems that are asking those questions constantly. We construct systems that are improving with time by asking those questions one after the other. Those questions correspond to 4 types of analytical analysis. The first one is the descriptive analysis, and the question is what has happened. This is basically an assessment of the situation. Then there is the diagnostic analysis with the question why did it happen and do you like it? If not, how can you improve the situation? Then there is the third one, the predictive analysis with the question what will likely happen. This is where machine learning shines. And this is where you construct a system where you give it an input and it will give you an output with a certain probability. And then the fourth one, the prescriptive analysis with the question, what is the optimal action? This is really a game changer and it's a paradigm shift in the sense that you are constructing a system and you are giving that system your desired output. What do I need to do if I want to improve my sales by 20%? This is the input. And the system will tell you what you need to do to get to that desired output. What actions do you need to take to get those 20% improvement in your sales? How do we do it? By combining machine learning, operations research, and other mathematical fields. In particular, for all problems, we always combine ML, machine learning, and OR, operations research. To combine both, there is at least 4 types of combinations. The first one that is now becoming mainstream is the use of ML and OR as 2 black boxes. Then there are 2 technical ways to combine them, which is to use one to improve the other. And it goes both ways. So you can use OR to improve ML algorithms and you can use ML to improve OR algorithms. And then there is a 4th combination where you really truly understand the fundamentals of ML and OR and you understand that you can combine them so that the weakness of one is obliterated by the strength of the other. And those are new algorithms and this is really our expertise. Here is an example of the first combination. So the combination of OR and ML as black boxes. Let's say you're a train company and you want to change or repair your tracks and you want to do this for a minimal cost. How can you do this? One way to tackle that problem is to do it in 2 steps. First step, you're using machine learning. So you're going to use cameras, you put them under your wagons, you let your train flow, and you take pictures. With machine learning, probably deep learning, you stitch those pictures together, and with machine learning, again, probably deep learning, you're able to detect the defects. You're able to say, oh, that track needs to be repaired in 6 months and it's type B to repair. Once you have that, you have a map of your network, but you don't know how to act, because maybe if you send a team to repair a track right away, maybe the track that is next to it shouldn't be repaired before 6 months, but because your team is already there, it's less costly to ask the team to repair the other track right away instead of sending another team 6 months later. And this is exactly what operations research can tell you. So that's a perfect combination of OR and ML as two black boxes. And now let me show you our AI platform and let's do a demo. I'm going to show you how we solve the logistic problem for a scene. So first of all, we launch a session by taking a JSON file with all the data needed to describe the problem, and we launch a new session. So we start a new computation to find a solution. So after a few minutes, we get an answer, and here you see the delivery paths, and you see depots and warehouses, and for obvious reason you don't see the map behind it, but it's a real map with real depots. And you can see that in that solution there are 85 trucks, and then if you, for instance, concentrate on one route for the truck 5, you see that this truck is actually going from a depot 5 or warehouse 5 to 13 to 5 to 10 to 5 to 10 to 5 to 10 to 5 to 10 and so on. And then you see that there are 85 such trucks. And this is the type of solutions we are providing. I hope you enjoyed this little video. We have a website, www.funartech.com, where you can find a lot of information. And of course, if you have any questions, I'll gladly answer them. Don't hesitate to contact us. Have a nice day.